Thank you very much for the invitation to speak to you, and welcome to our Australian guests to Wellington. And maybe later on I'll show you what the travel agents didn't show you, but more of that later. What I want to do is to look at a study we've been involved with, looking at the Canterbury earthquakes and some of the inferences we've got from some injury data. But I just want to set a wider context to this before I launch into that. And really it is what has been spoken of earlier today and by a number of speakers is really the role of the behavioural sciences into understanding how people respond to disasters, and therefore what is the public policy, what is the response, what is the measures that we need to take to prepare and to respond to events when they occur. This image here taken from the arrival of the tsunami in Hilo in 1946 resonates with me because it tells many stories in the image itself. You are seeing a group of people fleeing from, I'll put that out there, fleeing from a tsunami. You can just see it there, and this was the tsunami that hit Hilo, over 150 lives lost. And it was this event that led to the creation for the US territories of the National Tsunami Warning System in the late 1940s or 47, and then subsequently in 1960 it was extended to the Pacific Ocean. But what I was particularly interested in is what people do when events occur, that moment to which an event occurs, and what can we learn about that in terms of both the response to it or the types of impacts we might get, but also the education and how do we train people to make appropriate decisions. This photo here was taken also in Hilo in 1960. The difference between that earlier photo in 1960 is that the existence of a tsunami warning system. There was an earthquake in Chile and the community received the warning. There was a siren system and the sirens went off. But many people in this image have been in a place of safety. They have received the warning as the warning system did its job. They heard the warning, and the decisions that they made led them, for whatever reasons, and we can speculate what, to come down to watch the wave come in. Now, this was not the action that the authorities had thought the warning system would give. They were designed to make people move away, but actually the decisions that people make at the time of this, and this in this case is where there is a warning and there were several hours. What we don't know, and it may be the case, is that we know 61 people were killed, and many of those people, and there's been detailed studies of that, actually were in an area of safety, heard a warning, went down and were killed. So we don't know whether they're people in this image, but there is a chance that some of the victims of the tsunami were in this photo. So not just picking on behaviour from the US, this was 1960 in Gisborne, where this was when New Zealand was not part of the tsunami warning system, but the tsunami had arrived. And in subsequent waves coming in, these are the good folk of Gisborne who had informally, through social networks and stories, had heard that there was a phenomena down on the coast, and once again, this, in the eyes of most people, is inappropriate behaviour. This is not the behaviour we want from our citizens when a tsunami warning or message of a tsunami, but we still see this in subsequent events. So I'm interested in what people do, in this case with warnings, and we'll move on to the earthquakes in a minute. Just so we don't think it's the good folk of Gisborne that behave in this way, this is the photo of the good folk, some of the folks of Napier, who once again have received a tsunami warning. This was an event 2 days later in 1960 on the 26th of May when there was a massive aftershock after the Chilean tsunami, and there was a national warning spread out through New Zealand, and this time official warning was given, and once again many thousands of people around coastal New Zealand moved to high ground, and many hundreds of people moved down to the beach. So it was a minority of the behaviour of the citizens, but they have made a choice and done something to it. Now, once again, I was particularly interested in what people do at times of these events. So following the Indian Ocean tsunami in 2004, I was part of a group led by Chris Gregg from the University of East Tennessee State University and others who received some NSF funding to look, with partners in Thailand, to look at what people did for the Thailand tsunami. And we saw, in that case, there was no warning system for the Indian Ocean. And a survey of over 650 villages along the Andaman coast showed a large proportion of people had seen some natural cues, so 22% of people felt the earthquake. Over 70% of people reported seeing unusual behaviour of the sea. The ocean went out. 55% of the 600 sample reported hearing loud noises, and these were people close to the coast. But we only saw 11% of people actually evacuated. So once again, part of this study was to understand what are decisions people make at the time of the event. And in this case, there was a matters of minutes between, maybe sometime longer from the earthquake shaking, but only a matters of minutes from when the ocean perturbed to the waves came in, and many people were caught short. This is people fleeing. The behavioural science, or the research around human behaviour and disasters, goes a long way, and Kathleen outlined this morning many 60, 70 years of scholarship around this. So in the US, there is quite a lot of research around people's response to warnings, and some of the summaries that we find there. So once again, human decision making is well grounded in evidence. We understand a number of the factors that shape how we respond, and reasons why people respond in what may be termed inappropriate ways. And there are lots of reasons for that. So in a summary review paper of work done prior to that in 1999, many of the reasons were boiled down to three sources. There were sort of three main categories of reasons. So obviously the clarity of the threat is a key one. People do not perceive that the threat, even if they, to them, is there. So people may, I knew the hurricane was coming, but we had these before and I survived, so I didn't actually think I was at risk. One of the major predictors, and it's a very interesting one, is the social influences. And I think the sociologists and psychologists will tell you, and those who've studied and observed behaviour, and many of you will know, that social influences. So there's been those studies, those famous videos, and I don't have them, unfortunately, when there's an experiment in the US where a lecturer is giving a talk like this and the fire alarm goes off and he carries on lecturing and they're filming it, and half the audience are actors and half are just students who didn't know what's happened. And the first set of these experiments, the actors all get up and leave and everyone else leaves. But in the second and subsequent experiments, the actors just stay there and he carries on lecturing, and you can see the non-people looking around to see what people do. So that social influences at the time is a very key predictor. So moving on to what was the interest that I had following the Canterbury earthquakes and subsequent to that, the question asked to us was, we give this drop, cover, hold advice, and what is the evidence base to which we derive that from? Does it actually make a difference? So we know, and there's been a number of studies about earthquake injuries globally, and there's assessments of it, but we had the Canterbury earthquakes, and one of the things we were interested in, we had medical researchers looking at the earthquake, was what can we glean from the data about what actually happened to people and injuries that might give us some empirical support for this action? Does it make a difference or not? So that was really the basis to which I was particularly interested. And as many speakers have talked about, we have these exercises, and we've heard this morning from Kevin Ronan about the importance of school education and some of the activities. This photo here is not during an earthquake, this is during the shakeout drill, and this is the school in Wellington. So we're teaching children to drop, cover, hold, and adults as well. So can we tell anything about what we experience in Christchurch that would support this as action? Is it the thing to do? And how do we bring about earthquake safety? So I'm just going to spend some time now just going an overview of what happened in Canterbury and some of the evidence for that. So who in this room was in Christchurch for any of the earthquakes or aftershocks? Okay, so many of you went through this, and I will just go over very quickly because there are many, the majority were not there, but some of the reasons for it. So the Canterbury sequence, as many of you will know, there was the first earthquake around 7.1 on the 4th of September 2010 near Darfield. There was significant damage. There were 6 serious injuries. There was no loss of life. But we still had 2,500 injuries, and I'll talk about the injury data set that we've got in a minute. And then subsequently there was the more devastating event on the 22nd of February directly underneath the city. So we had, which led to 181 fatalities, around 180 serious injuries, and there's some definitions, but from the medical point of view, but over 7,500 injuries from the ACC injury database. And really what I was particularly interested in is from that pattern of injuries, can we understand and infer some of the actions or some of the evidence for the actions that people took that might lead to injury or injury prevention or saving loss of life. The event was so powerful, and this cartoon to me is the best image to answer the question, why was the 22nd of February so devastating to the city? If you had to design an optimal fault structure to do the most damage to a community, you could not have done a better one. You had very hard rocks directed straight into a city sitting on a swamp, a big sponge, and the energy was directed upwards. So the vertical acceleration, even for a relatively lower magnitude event, 6.3 is not a massive earthquake on global scales, but the geometry was just the worst luck you could have, and it directly hit into the CBD, and we saw the consequences of this. The most catastrophic one and the most sad thing for many people was 115 lives lost in the CTV building, and subsequent responses to that. We had 18 more lives killed in the Pinegold Guinness building, and just this sort of summary of it. So what was devastating really was this peak ground acceleration. So the larger magnitude 7.1 away from the city was not as devastating to those directly under it than the Canterbury earthquake. What was also disturbing and has made us think a lot around our earthquake safety was the response to unreinforced masonry buildings. Many of these buildings were damaged severely in the 4th of September earthquake and subsequent collapsing of the facades. If you see the fences here, this building was due to be demolished, but it hadn't been removed and it fell outwards. So 46 lives were lost by the falling of these structures onto people. In particular, in Colombo Street, one block, there were 17 people killed on that one block. Outside the cordon, these buildings were due to be demolished. They were fenced off, but the masonry fell outwards, leading to 17 lives lost. So the loss of life and the serious injuries were mostly attributable to the failure of buildings, and at the time, with a few exceptions, and we can talk about those few exceptions, were unpreventable to those exposed to them. There's not much you could have done at the time of shaking. But we also had a very large set of data from the other injuries, the large tail of injuries, the 2,500 in 2010 and the 7,500 in the February 2011 event. What is interesting, and we'll go through some of the numbers very quickly, and I won't dwell on them, there's a paper on this that goes into more detail, is that we had a almost 2-to-1 male-female ratio of injuries, and we've got some conclusions I'll try and draw on that. One of the tasks that we were able to do, because everyone injured in New Zealand who received medical treatment from either a GP or the hospital or a doctor or any form of official, the payment for that was from a form that was filled in. And on that form, there was a line, what was the cause of injury? So we had 9,500 forms with this descriptor. And I'll mention her by name, Sarah Standring, a medical student, spent an entire summer coding all 9,500 entries, looking at what we could glean from that about what people said they were doing at the time. And what came very clear from that, and comes out very clear in subsequent research and from some other studies, is that there were two primary ways that people were injured. They were injured, what we call primary immediate, by things hitting them. They were hit by objects, fittings, bricks, buildings fell on them, and they were injured that way. But what we found is that there were a whole lot of injuries that were caused by people hitting things. They were doing an action that led to the injury. And from an injury prevention point of view, and our Accident Compensation Corporation that covers the injuries was very interested in this phenomena, and we were able to glean this from these descriptors. So many people were not actually injured at the point of the earthquake. They were injured seconds afterwards. They were injured doing something afterwards. And these were not the serious injuries. They were mostly caused by what we would call the primary immediate, but the action injuries were the big tail, and it cost the accident compensation over $20 million, plus any additional social costs from injuries. So it's probably maybe several times more that. So it was a big cost. Now, traditionally, earthquake injury data globally really just looks at the severe injuries. It doesn't look at these minor injuries, and very few places in the world can you get a data set. What we were also interested in some of the injuries that occurred afterwards. So there are a number of injuries in the day to a week afterwards, and there are a whole lot of injuries caused in the secondary activities, and we'll look at some of those numbers now. What we were also able to do was to answer the question, who was most vulnerable to this earthquake? Now, traditionally, older adults and younger people are vulnerable to disasters, but actually, if you look at the numbers, we had a disproportionate number of children injured, which is very pleasing for a nation that wants to protect children, and we had a disproportionate number. They were much skewed to the older adults. So it was the older adults were injured by this event, and we can start to explain some of the reasons, and there are complex reasons why, the time of the day, the location, what people were doing. But what was particularly interesting and is encouraging, unlike many other events recently globally where older adults and children have been disproportionately affected, it was a bit of luck as well, but children were not injured in a way at the levels of the other population. So that's quite pleasing. What we were also able to glean from this was the tale of two earthquakes. The earthquake, the September the 4th earthquake in 2010 occurred at 4:30 in the morning. People were in their houses generally. There were a few people out drinking on the streets, but luckily, if you look at the damage to unreinforced masonry from the first earthquake, many of them fell onto the streets, but that occurred at night, so they did not injure people. People were injured in their households, but actually about 3/4 of the injuries, I'll go to this slide, then jump back, 3/4 of the injuries were actually action injuries. People were injured getting out of their beds and doing something more than any other cause in the September earthquake. And it's quite obvious if you're in bed. So once again, the evidence and the advice is if you're in bed during an earthquake, stay where you are. People were injured taking protective action they thought they should do, go to the doorway, and actually were injured. So I've always wondered about this go to a doorway, because to me a door is a large wooden object and it's on hinges and it flaps. So we're telling people to move towards a large wooden flapping object to protect themselves. It makes no sense, but there is that folklore and tradition that we say to go to doorways, and there was a reason for that. But actually, I do not recommend people to move towards a large wooden flapping object as a form of protection. So actually, from the evidence, the advice to stay in bed, do nothing is better than doing the wrong thing, and that's another conclusion, unless there are factors. And I think that there are people who did avoid, and there are many stories about people who dived away and got away from chimneys falling down. So falling down chimneys, and they're very vulnerable, and we saw that. Now, in the daytime earthquake in Christchurch City, it was a different story. It was actually passive injuries, we call them, things hitting people was the major cause of injury. The numbers are much larger in both categories, 2,500 versus 7. There were much more serious injuries. So for a big earthquake in an urban area during the day, being hit by objects, but in many cases there was still a significant number of injuries caused by people taking action or doing things around it. So we also were interested in the cause of it, and I won't necessarily go right through all but we saw this was the September earthquake, the Darfield earthquake, and trips and falls were the most common, and once again, that was people moving around in the dark in their houses was the cause of injury. Not necessarily the shaking itself. Some of them were moving during the shaking, but if they had done nothing, they would have. But the second most biggest category is during the cleanup operation. So the Accident Compensation Corporation, once again, we see a lot of people injured during that immediate aftermath of the event, and it needs to be factored into the advice we give them. And some of the other categories, these were not just one or the other, so we looked for, in the descriptors, people going to children, people going to animals, some other sort of factors that cause the injuries. And we see, once again, the order of things changes a little bit for the daytime event in the Christchurch. And once again, I'm not a medical person, but they've got a whole lot of breakdowns on the types of injuries. So lacerations and sprains, as you would expect for this long tail of what are relatively minor injuries, but they were significant to many people, and there's still further analysis to do with the working with ACC to look at the cost of those injuries in terms of other payments that they made. And once again, we can look at some of the gender differences from these events, and we see once again there was a disparity, almost a 2-to-1 female to male. Now, some of the explanation for that, and I think other independent research, we do know for the tail, and this is not too surprising, men don't like to ask for help. And we see that, we think, in the accessing medical treatment after the earthquake. Because all things being equal, we originally thought, when they first analysed this, the medical people from the Otago Medical School, that the first set of data they only looked at was the February, and they thought it was due to the numbers of people in the central city. But when we saw the exact same pattern with September, when the population was evenly distributed and mostly in households, we still saw this 2-to-1 ratio. And once again, we can look at where people were during the time of earthquake. So I'm just going to summarise that and they've said they moved my slides along, so we've just lost, and I'll read that out. So the gender differences were significant, and the causes are varied, and I think we need some further work why there was this 2-to-1. We think it is due to locality for some of the serious injuries. There were more women working in the central business district at the time of the earthquake where a lot of the injuries were, but we also saw access to healthcare as a key one. So in general, improved building codes, strengthening buildings, securing fittings, stopping people being injured by things hitting them will reduce future deaths and injuries from earthquakes. That's a given, and we've got a major review of unreinforced masonry or the building codes in New Zealand, and we're learning from that. However, and this is the however that I think has been missing from a lot of the work to date, is that even if we had solid structures and things didn't hit you, we're seeing a very high rate of what we call action injuries during and after an earthquake that is leading to people being injured. And structural mitigation, stronger buildings codes will not fix that. And it's really teaching people what to do during an earthquake. So I said I'll go back to the case, and it's an unfortunate case of some of the fatalities, and we know at least 2, where people were inside buildings, and Joe's Garage was a cafe in Christchurch. Unfortunately, there were about 8 people in the building, and 1 person ran out, and he was subsequently killed by the parapet falling down. So actually, at the time of an earthquake, the decisions you make can determine the outcome for you. And in most cases, in developed countries with strong building codes, you need to think about what you do. Now, this work isn't a New Zealand context, and we have to be mindful that many of these numbers are different. In the Pakistan earthquake, just the wholesale collapsing of structures meant that actually trying to leave might be a good idea. But in a New Zealand or a US context or an Australian, doing an action during the earthquake actually doing nothing might be better than doing the wrong something. And we need to look at that. So to date, earthquake models globally for injuries and loss treat humans as passive objects. They have looked at the injury database and they look at the building types and they have curves for fragility. But I think this evidence out of this study and many others shows that human behavior is a key factor, and we do need to educate people what to do during earthquakes, and it will have a significant impact on future injury prevention, and we need to look at that. So this is where I'm going to move into a future looking at what can we learn from this in terms of and this is what the travel agent didn't tell you story comes in. So sitting, as many of you know, New Zealand sits on a plate boundary, and sitting underneath us about 40 kilometres is the interface between the Pacific and Australian plate. The Australian plate, like Australia, is trying to ride over the top of New Zealand, and the Pacific part is resisting it, and sometimes it gives. And so we have a locked plate boundary underneath us, and it is very similar to what we had in the Indian Ocean in Cascadia and in Alaska. And I've just been with some others to the 50th anniversary. There's a conference on earthquake engineering for the '64 Alaskan earthquake, and it's a good analogue to what could happen in New Zealand. And I think they put the fault there. So we are there. Anyway. So we have faults through Wellington, and they could be destructive, but actually the plate boundary is also a problem that we need to do. So very interested in looking what that will mean. Now, as I mentioned, '64 Alaskan earthquake, a magnitude 9+. This generated tsunami as well that affected the US and New Zealand. Was a major destructive earthquake to Anchorage and many others. And what I was particularly interested in is what would happen. So what we know from an event like this, being 40 kilometres down, is much further from the source of the energy than the Christchurch earthquake. So the peak ground acceleration, the force, will be less than you had in Christchurch. But Christchurch earthquake was about 20 seconds or less of shaking. This event will go on for about 4 minutes. So you've got slightly less acceleration, but you've got 4 minutes of shaking. And this is going back to about what people during an earthquake. My prediction is that if people, during that, it's a very long time to be hanging on there, and I think we will see, if you're not injured by things falling on you, and we should be designing our buildings and our fittings to sustain 4 minutes of shaking and not to land on you. But during that period of time, I would predict many people will want to do something, try and get out, or will be freaked by it. And if you're in a safe building, the best thing is just to stay there for those 4 minutes. But I think that would be a very difficult thing to do for many people. And I think that's where we need to think about the messages and the training we give people, because an event like that will occur. However, there is a sting in the tail to this event. And in 1964, most of the lives lost was from the tsunamis following the earthquake. And I'll go back, because unfortunately, the subduction zone is about 30 kilometres off the coast, out that way, and we would expect the tsunami to wrap the coast of Wellington and the Wairarapa and up to the north from this event. And those in the tsunami inundation, those below the blue line, but this wave will not arrive for between 15 and 20 minutes or longer. So the question is, if you're in the tsunami zone, do you wait your 4 minutes, wait for it to stop and then move, or do you want to move away if you know you're at risk? And I think that these are tricky decisions, and I'm not sure if we've totally thought through what advice we give them, because we would expect, I think from the evidence we have, staying put to the ground shaking stopped and then moving to high ground if you're a vulnerable population. And we've now demarcated the areas of vulnerability much better than we have. It's something that we need to think about. So there are still some practical lessons, but also some thinking to do and about the education we give for our citizens, and especially children, the role of shakeout and preparing them for events that are not going to be totally unpredictable and without good analogues to show us. The majority of people not in the tsunami inundation zone in Alaska survived this fine. There was a few fatalities from landslides and rock falls, but most people, where the shaking was less than Christchurch, but longer, they survived, and many wooden frame houses were fine. And so just imagine sitting here for 4 minutes as the ground is going up and down. It will be a very frightening experience for many, and we need to think about what it might mean. We have another little sting in the tail, and Napier really gives us an insight to that. And unfortunately, it is the fire that may follow as well. So like San Francisco, like Napier, fire following earthquake is a very real threat. So once again, and this is moving into territory that I have not explored yet, and it would be worth a conversation with my fire colleagues, is to what degree, without a fire service to be in assistance immediately after this, can the actions of citizens stop the spread of fire, or should we even try? Because we saw in Napier, the earthquake shaking, there were many trapped people who were then inundated by the fire. It's not described much, but there were actually people who were trapped alive, and the fire following it was the cause. So the degree to which citizens can fight fires is something that I would like to put out there as a question that I would maybe look for some assistance and is it something we think about, or we just leave it to chance? And this was the images of Napier. So I really want to use that to end my talk, and I think we need to both learn from the Christchurch experience, accept the differences, but draw that into both the education. What advice do we give them? What is the justification for teaching children to drop, cover, hold? And I think that's important. I would suggest maybe we look to, or at least contemplate in the education, if not the phrase, stop, drop, cover, hold, or stop, drop, cover, because doing nothing is better than doing the wrong thing. And we saw many injuries, and in some case loss of life from an inappropriate action. So before we do anything, you're best to stop and make a decision. Now, you might decide to jump sideways because you're beside a building or into a doorway, but the first thing we need to do is to teach people to get some situational awareness, and probably dropping and covering is the best thing, and I think the evidence is quite clear from the study and many others that that is good advice. Thank you very much.
Thanks very much, David. Do we have any questions for David? And there are microphones around the sides.
Hi, thanks for the talk. I was just wondering if you had any data from examples where people weren't injured and what they did. So you were talking about how the data was based on injuries, but it'd be interesting if there were studies that looked at what people did and weren't injured.
So, yes, in addition to this, we've done some more random surveys of populations about asking people what they did. And there is a study, I think, in press that Mike Lindau did in both New Zealand and in Japan. And I think looking at what actions people did, so it's a randomized sample of 500 odd people, what we're finding is that most people didn't do much, but the drop, cover, hold is less than 20% of people actually did what we tell them they should be doing. Much higher uptake in children and younger people. We've got a second study running, and it's because we haven't captured as much, looking at CCTV footage, and we've had a student developing a coding schedule for analysing that. So it is our ambition, and maybe this is an invitation to anyone who holds any of this, we have got the images from the hospital with strict ethics clearance, but we can't share them, is looking at the behavioural response of actual people from CCTV footage. So my aim our team's aim is to look at every person from every frame, from every image we can get from Christchurch, to really give us a solid empirical base to what people do. What we do see from it is that actually drop, cover, hold is still a minority of the population, and people are still doing stuff around, which maybe is not the most wise thing to do.
Other questions? Hang on a sec, John.
Thanks. Is this there? Yeah. John Nan from the Bureau in South Australia. I'm interested in the rate at which you collected the data and you revealed the data. Is there any sense of need to speed up the assessment that you're actually doing rather than an entire summer to get the information back?
I think, well, it's the great research question of, I mean, we, in some ways, have stumbled over this. The analysis had been done at a level from the medical perspective about the types of injuries. A paper had been published, but the medical researchers were not necessarily looking at behavioural response across the data. So we sort of stumbled over this, and suddenly it occurred to me, with such a large sample, and in sense of people who received official medical, this is not a sample, it's a census. So we have the records of every person, and we can tie it back to their medical records. So we got a much greater, it was too good an opportunity, but I had to raise funding, get ethics approval, do all of that. So that's why the paper came out last month in Natural Hazards. If anyone wants the reference to it, I'm happy to share that, where we do the analysis. But I think I would go back to, yes, we need to be, I think we need to get much better empirical evidence about what people actually do during these events, and that really can give us greater confidence that the advice is correct and the balance from it. And it's really working with the medical people who have this as their ethos, that there needs to be good evidence for practice, that we started to look at that. What is interesting, this is a study where we've brought together geologists, engineers, sociologists, psychologists, and medical people for different reasons, because the earthquake engineers want better data for modelling casualties and strengthening. We need the public policy for the earthquake-prone building policy in New Zealand. What we saw from the response of the unreinforced masonry buildings, not only was there the loss of life, there was actually quite a large injury and cost to society. To date, that has not been fully costed. We don't actually have all that data together. What was the true cost, economic cost, as well as the social cost of people injured? And I think the economic cost hasn't, there's many stories about the social costs, and we can hear that from, but we don't even have the economic cost yet of this event, other than just the cost of treatment at the time. But a whole lot of people were injured and didn't work, and other flow-on effects from that.
Time for one more question.
So thank you for your presentation. So it's a very a nice empirical finding, but I think we also need to consider the counterfactual, like the people who choose not to move. So what happened with them? So, and it is also very, in terms of a research perspective, it's very hard because maybe they didn't survive. So, so based on that kind of data set, our empirical findings could be biased. So that's one. Then the second thing is that, if the people choose to move, so maybe some part of the people, they are just partially injured, but most of them, they are escaped from the situation. So how to deal with that sort of scenario? Thank you.
I totally agree. We don't hear the voices of those who didn't survive. We don't know to what degree did people, there were 18 people killed in the Pine Gord Guinness, there were many people injured. We don't know the degree to which their actions prevented loss of life or contributed. So there are a lot of unknowns. In terms of looking at what people do, and this is the work that we want to do in the future, is that now our cities are wired up. If we have an earthquake in Wellington, and we've got some from the most recent event, there are several hundred, if not 1,000 cameras filming people. And I think we need much more rigorous assessments of what people actually do in these events to give a much better evidence base. And that can be collected quite quickly. And really, because it is biased, we're only looking at those who are injured. We don't know about the 300,000 people in Christchurch who were not injured. And that's a large number. So it is, correct, it is a biased, but it does give us some insights, at least from their descriptors, about their causes to them. It doesn't tell us about the other group, and I agree with you, that's important.
Thanks very much. Would you all please join me in thanking Professor David Johnston?